Hi, good day to you, and welcome to my channel where I tutor you in science for free. The topic in this video will be the introduction to organic chemistry. In this video, we'll be talking about the basic concepts and rules that apply to the remaining chapters of organic chemistry, like alkanes, alkenes, and for the pure chem will be the alcohols and carboxylic acids. Okay, so what are organic compounds? Organic compounds are carbon compounds because carbon can form many bonds. They have 4 valence electrons, so they can form 4 covalent bonds, and they are pretty stable. So you don't want an organic material, say for example your skin, to quickly have reactions with things around them. So nature chose carbon to represent organic compounds, and organic compounds are mainly formed by carbon and hydrogen. And for this video and the remaining organic chemistry topics, we'll be covering mainly on things like hydrocarbon. Hydrocarbons are compounds that are formed only with hydrogen and carbon. So things like alcohol, this is a molecule of alcohol. Look at it, it contains an oxygen, so it's not considered a hydrocarbon, but it still mainly contains carbon and hydrogen. That's why it's a point of interest for organic compounds. Okay, so next we talk about homologous series. So every time you look at this, is like you can think of it as a family. So homo means the same, logous means alike. So these same class, same classification of chemicals, they look the same, they have the similar names, they behave the same chemically, takes part in very similar chemical reactions. So of course for secondary school level, we'll be covering only alkane, alkenes, alcohol, and the carboxylic acids. And each of them will have their own functional group. The functional group is the point of interest within the molecule that takes part in reactions in a certain way, and of course it being in the same family, they will participate in the reaction as expected, having similar results and outcomes with their counterparts in the same family, the same homologous series. So alkanes don't really have a functional group. They are fully filled and their reactions will happen at any one of these bonds because they are pretty much the same. For alkenes, it will be the double bond. For alcohols, it will be the OH. And for the carboxylic acids, it will be the COOH group. So general characteristics of homologous series, the families they have the same functional group. Same functional group, similar chemical properties means they pretty much participate in the same kind of reactions. And a trend observed in their physical properties like melting point, boiling point. And because we are talking about classifying organic compounds, they are in their families, and families have same names. And names are split into 2, prefix and suffix. Prefix is the name in front, like your first name, and suffix will be the name at the back. So it's like John Smith, then there's Jane Smith and Jack Smith, things like that. So the first names are derived from the number of carbon atoms they have. So if they have 1, it'll be this, 2, 3, 4 will be these. And moving forward, there's like 5, 6, 7, 8. We'll just use the polygonal names. So Me, Pro, Bill will be the names you will need to know. And 5 onwards will be like pentagon. So use the first word pen. 6 will be hexagon, hex. 7 will be heptagon, hep. 8 octagon, oct. 9 nonagon, non. 10 decagon, dec. But should only, be more familiar with the first 4. And the suffix, the so-called last names of the families of these will be similar to the name. So alkane, you just take the last 3 words, the ane, and alkene will be ene, alcohol will be all, carboxylic acids will be the oic acid. So combining them, so let's say if it is a 1 carbon alkane will be the methane, 2 carbon alkene will be an ethene, 3 carbon alcohol will be propanol, 4 carbon carboxylic acid will be butanoic acid. So this is how it works. You can mix and match them as per how you see the molecule, and you should also learn how to draw them. And in secondary school level, all the bonds are in 90 degrees. It should be fine. You're not tested on VSEPR theory, valence shell electron repulsion, so it's okay. Everything is 90 degrees, it's okay, it's fine. Just remember that every carbon atom has 4 hands, every hydrogen atom has 1 hand, every oxygen atom has 2 hands. So the hands hold on to each other and make sure that they are well accounted for. So common mistakes will be carbon having 5 hands or hydrogen having 2 hands, things like that. So a lot of these, they come from petroleum and natural gas, they have to be dug from the ground, usually drilled by oil rigs. And these are formed by decomposed fossilized metal from long ago. And because they come as a mixture, they have to be fractionally distilled. The one that is being drilled outwards will be the crude oil, the raw material, and they have to be refined by fractional distillation. So because of the small molecules having lowest range of boiling points, they will evaporate first and they are collected at the top. And as temperature increases, the whole range of other fractions will also be collected in the respective pipes. It's good to be familiar with. I would like to remember usually like this is called punks and delinquents, P and K D L. So the first and the last, usually I don't have to forcefully remember it because it's pretty straightforward. The gas are always the ones that are floating to the top, and bitumen are always the one leaking at the bottom. So the boiling range are these, the number of carbon atoms are these. Just get a good sensing about it will do. And the uses are these. So first one, petroleum gas for cooking, heating. This cooking and heating always comes together. So petrol, of course, we all know that petrol is for cars. Naphtha is for these, feedstock for all kinds of things, for plastics and detergents. Kerosene, has the arrow within the word, so it's for aeroplanes. And remember cooking and heating? Yeah, cooking and heating as well. Over here, kerosene lamp and things. Kerosene stove in the past. Okay, diesel is also for vehicles. Lubricating oil is for lubricating machines and making slippery stuff like waxes and polishes. And lastly, bitumens for road. And of course, petroleum is used for a lot of things to generate energy, electricity, move vehicles and things like that. Because it is also a non-renewable resource, and we should always aim to reduce and look for alternative sources of energy like hydrogen, electricity, nuclear, things like that, and don't use resources willfully and wastefully. Okay, next, so fuels are hydrocarbons, and because they contain a lot of hydrogen and carbon and you burn it, burning means adding oxygen into something. So if you add oxygen to carbon, it becomes carbon dioxide. If you add oxygen to hydrogen, it becomes water. So a lot of the chemical equations are just like that. You add oxygen and they just become carbon dioxide and water, and you just balance out the equation and it'll be fine. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe and share it with somebody who needs to see this. And I will catch you in the next video. Bye!